In this video, I'm going to talk about RMap, what it is, how it works, and I'll be giving a demo. RMap comes out of this idea that while in the past much of the focus of scholarly works was around articles, with citation lists being full of other articles, these days things have become much more complicated. Citation lists have started to include things other than articles, and with new focus around open science and reproducibility, as well as increasing pressure from publishers and funders, more and more types of work are being shared, and these might be shared at different times and in different repositories. So you can see how an article citation list could be quite restrictive if you're trying to capture this new complexity. And that's where RMap comes in. So what RMap allows you to do is express the map of works as linked data, and then capture and preserve that map. And we call these maps DISCOs, which stands for Distributed Scholarly Compound Object. And just to note, the files themselves are not preserved, just the map that describes the connections between them. So, as a researcher, for example, you can express how all of the different components of your work fit together and where they can be found as a DISCO. And then this can be cited or shared with others to clarify the scope of the work, and it can be updated as the research evolves. So just to explain a bit more about what a DISCO is, at its simplest form, a DISCO describes an aggregation of one or more scholarly resources. So in this case, it's an article and a dataset. Optionally, you can add as much context around this as you like. So you might choose to describe the relationship between them, and you might add information like title or dates and express who contributed to the different works. When the DISCO is created, the creator receives an identifier so that the map can be shared or retrieved at a later date. DISCOs are also versionable, so as the work evolves, you can update the DISCO to represent all of the latest components that are available. The previous versions will still be available. So the primary service offered by RMap is a REST API, and this allows you to manage and retrieve the maps of relationships as linked data. If you're looking at a DISCO through the API, it'll look something like this. This is Turtle RDF and is available without having to log in. To make it easier to see the DISCOs without using the API, there's also a graphical user interface, and this allows you to navigate through the DISCOs using a visualization. If you have a DISCO ID, you can enter it here, or you can enter some keywords. The visualizations are interactive, so you can click on things to see more information, or even navigate through the map. This way you can discover more connections between things. So an ideal DISCO created by a researcher might look something like this, with all of the components expressed in one DISCO. In reality, things tend to be more piecemeal. Things are created at different times and by different people, so information is likely to be fragmented. But the good news is that the nature of linked data means that these will eventually connect up as more and more pieces are added. So for example, a researcher might represent her work as a DISCO, and it might include data that was generated using some software, and it's described in a paper. So here's that DISCO as a visualization, and I've added a bit more detail than I showed in the diagram. I'm going to switch to a larger view. So first of all, we can see this icon, which represents the DISCO, and it shows that it's aggregating three different kinds of objects: an article, a dataset, and some software. I can take this out of the view if I just want to focus on the research components. So you'll see here, for example, that the software used several algorithms, and it's documented over here. You can also see each component has different contributors, and you can see how the pieces are connected together. And I should just note at this point that although this is a real data set and these are real connections that I'm demonstrating, I have simplified a number of these to reduce the number of citation connections, just so it's easier to follow along. So now that we have this one DISCO from a researcher, say there was another DISCO that was harvested from a publisher, and this happens to show two data sets that were used to produce an article. In RMap, the DISCO would look something like this. So this time the focus of the aggregation is an article, and you can see a connection to the two data sets. This one being the one that we saw in the first disco. So what we have now is a combined view that has more context than either disco had on its own. And because many of these works have identifiers such as DOIs or even URLs, where these are used consistently, these maps can begin to join up. So at this point, you can ask RMap everything it knows about a particular resource, and it will combine the data from all of the discos to provide this view. So if we return to this disco that we were just looking at, and we can find the data set that was from the first disco, we can actually put this at the center of the view. And note that this is changed to resource summary because we're asking RMap what it knows about this one resource. And we see over on the top right that this view is formed from 3 different discos. So this view combined is providing more context than any one disco alone. And you can see now this data set, as well as the contributors. We now have 2 papers and another version of the data set and the software all connected in this one view. And again, a side note, this data set in particular has over 50 citations, but for the sake of the demo, I'm just showing a couple of them here. So we hope this demo has been useful. Please feel free to contact us with any questions, and we look forward to providing more updates in the future.